Hi students, now I want to take you back to 8th grade, really, and looking at these systems of equations. And I want to organize them in different matrices. I'm going to start with these three, the coefficient matrix, the unknowns, and the constants. So if let me get a different color. So if I have this system, which is just a system of linear equations, I'm using something kind of easy. You know what, I want to change this to a minus. I'm using something a little bit easy to show you how it works. My coefficient matrix would look like this. 2x minus 3y, 3x plus 4y. In other words, my x's go in this column and my y's go in this column. And then my unknown is going to be x and y. Let me show you why that works. If I were to put this together, if I multiply these two matrices, which is defined because a 2 by 2 can go by a 2 by 1, what would happen is I would say 2 times x, look at me working that dot product, minus 3y. See how that works? And then 3x times plus 4y. So I'm just undoing the dot product when I work this out. Now my constants are 16 and 7. So that's how it works. Let me do another one for you. And let's take this one. So it would look, I'm going to do this, like this. 3, 1, 2. I'm going to go ahead and do my x, y, z. That's the way it's going to look. They're going to be 26. Then 0x, negative 1y, positive 5z is 39. And then 2, 1, 4 is 117. So at this point, we're just setting those up. We're not solving them. Sometimes they don't give them to you in that order. Let me give you an example. Okay, I totally made this up. It's not going to make any sense. But if I had something like this, where everything isn't put in standard order, the way that one was, I'm going to put them in standard order. I would say, so 3x plus 2y is equal to 9. Then 1y, well, I'm going to make this 0. I'm going to subtract 2x from both sides. Negative 2x plus y is equal to 0. And then here, I'm going to subtract these two. And in other words, I need my constants on the right and all the variables on the left. So this is 5x minus y minus z is equal to 0. So the first thing I have to do is put them in that kind of order, and then I can do my matrices. 3, 2, 0, 3x, 2y, 0, z. Negative 2x, 1y, 0z, 5, negative 1, negative 1. And then I would, of course, do my x, y, z, and then my coefficients of 9, 0, 0. So you can still do it. You have to pay attention to the way it's given to you. Now I'm going back to the top to reinforce that this is the coefficient matrix because it's just a coefficients. Here's my unknowns and those are my constants. But what if they asked me to do an augmented matrix, which is, by the way, my favorite? And here's what I would do. You go, augmented matrices, the placement is understood that I would put 2, negative 3, this little line, which I often forget, 16, 3, 4, 7. So in other words, my equal becomes this little dotted line. I drop all my variables, and this placement is understood. I've put the like variables up and down. Here's my x's, here are my y's, here are my constants. If I had this equation right here, let's do this as an augmented, it would be 3, 1, 2, 26, 0, negative 1, 5, 39, 2, 1, 4, 117. So if you compare this to what I was doing before, all we've done is we've taken the coefficient matrix and the constants, put them in the same matrices, and dropped the variables. Because the variables are understood. These are all like terms. These are all like terms. These are all like terms, and these are all my constants. And it makes it a lot easier to work with, unless you're doing elementary row echelon. Let me explain what that is, and it's going to make you miserable. Okay, I'm just going to do one example and tell you this is not for the faint of heart. I like these. And here's what you do. If I had 2, -3, 16, and 3, 4, 7, I need to get this down to my identity matrix. In other words, I need this 2 to become 1, and the y to become 0, and then some number be there. I need this to be 0, 1, and see what happens there. In other words, I got to get this to be 1, this to be 0. I have to get the second row to be 0 and 1, and the constants will be super useful to me. Now, I would never do well, let's just do the process. I know you're going to tell me I could do this faster with the system, but you couldn't if there were 3. So I'm just using 2 as an example. And here I go. I need this to be a 1 and this to be a 0. So the first thing that I'm going to do is, I think I'm going to subtract the second row from the first. You can only work on one row at a time, but you can use the other row to do it. So in other words, I'm working on this row by subtracting the second row. So since I'm working on the first row, my second row stays the same. So what is 2 minus 3? Remember, I'm working on the first row. 2 minus 3 is -1. What is -3 minus 4? -3 minus 4 is -7. And what is 16 minus 7? It is 9. So in other words, I've worked on my first row, and I used the second row to do it, but just the values. I left the second row alone, because you can only work on one row at a time. So I took row 1 minus row 2, and that's what I did. I'm only writing this so you'll know. And this is my result. Now, here, I'm going to multiply row 1 times -1. Because so I'm leaving the second row alone, so just bring it down. And if I multiply this top one by -1, I get 1, 7, -9. So I've accomplished something. I've made this one. And I like that. So now I have to take row 2, and work down. Don't work across, always work down. I've got to make that 3 a 0. So in order to make that 3 a 0, here's what I'm going to do. I'm going to multiply row 1 by -3. And I'm going to subtract it. So row 1 times -3, and I'm going to subtract it from row 3. Subtract that from row 3. So in other words, while I'm using the values of 1, I'm just using their values to work on row 3. So I leave row 1 over here because I like it. It's got a 1. But if I take 1 times -3, I get -3. And -3 plus 3 is 0. If I take the 7 times -3, I get -21. And 4 minus 21 is -17. If I take -9 times -3, I get +27. And when I add that to the 27, I get 34. So again, I multiplied all the values from number 1 by number -3 and added it to this row. And here's what I got, which is perfect. I got 1, 0. I don't want to mess that up. So I come over here and I'm thinking, what can I do over here to simplify things? I've got, can you see that row 2, I need this to be a 1. I need that to be a 1. I need that to be a 0, but I can only do one thing at a time. So I've decided to take row 2 and divide it by negative 17, because that would give me a 1, and that would leave the 0 alone. So I got 1, 7, negative 9, but because I'm leaving that row alone, row 2, 0 divided by negative 17 is still 0. Negative 17 divided by negative 17 is 1. 34 divided by negative 17 is negative 2. And here's the value. I am done with this row. I can use it for its values, but I'm not going to convert it or prevert it, whatever you call it, at all. So here I go. I'm going to leave row 2 alone. But on row 1, I need this to be a 0. For that to be a 0, I decided to take row 2's values and multiply by negative 7 and then add it. Because when I take the 0 times negative 7, it won't mess up that 1 because it'll be 0. But I can turn this value into, I'm going to multiply it by negative 7 and then, add it to that. So here we go. 0 times negative 7 is 0. Add to the 1, and I still have 1. 1 times negative 7 is negative 7. Added to the 7 is a 0. Negative 2 times negative 7 is 14. Added to the negative 9 is 5. And I have my answers. 1x plus 0y is 5. 0x plus 1y is negative 2. So x equals 5, y equals negative 2. I'm just showing you a process. Don't panic yet. I just need you to see that I created a coefficient matrix where I've solved the x and y. Okay, breathe deep and take care.